So if we graph sine of x and cos of x from 0 to pi over 4, well, I'll graph a little bit more of sine. I'm going to start by marking 2 pi along here. There's pi over 2. Sorry, there's pi. This would be pi over 2. This would be pi. 3 pi over 2. If we think about our sine graph, I'll graph sine in blue. It goes up to 1, down to minus 1. There's our standard sine graph. And if we do cos graph in green, there's our cos graph from 0 to 2 pi. These two graphs intersect right here at pi over 4. Because at pi over 4, sine of pi over 4 is root 2 over 2. Cos of pi over 4 is root 2 over 2. So now if we zoom in on this little bit and we say to ourselves, we want to find the volume between sine and cos. So if I color in between those two, I want to use a new crayon color. Like there. Some sort of silver. Okay. There we go. That little bit of silver. Now if we take that part in between the sine curve and the cos curve, or in between the cos curve and the sine curve, and rotated it 360, what kind of shape would that make? How would you describe that? Well, I'm going to draw it a little bit bigger here, just so that we can see it better. I'm going to put pi over 4 right here. I'm going to put 1 up there, negative 1 down there. We would have, just taking that part, it seems like it's about there, cos curve like that. That we drew in blue before. Sine curve went down like that. We're going to rotate this 360 degrees around. What would that shape look like? Well, if I draw that same point down here, redraw my green graph there, my blue one there. Can you see that's just a flip? If we rotated it, we would have this. What would that look like? Like a dog bowl turned on its side, like a dish? Can you see that? So if I color it in to help you see it a little bit better, if I use my crayon, we're making, this is your favorite dog. So you want to make this dog dish out of silver, solid silver. And so we've got to get that silver color again. Gold was yesterday's news. We're moving on. Should we say platinum? Is that like a step up from gold? Okay, so today's platinum. This is a platinum dog dish for your dog. What's that? Oh, you've already taken out your silver pen? I'm sorry. You're going to have to take out your platinum one. We're moving on. So we got our platinum color here. I'm going to color the outside of my dish. And really, the coloring can sometimes really help you see what's going on. So there is the outside of my dish. I'm going to color the inside of my dish a little bit darker than that. That looks the same to me. Does it look the same to you? Okay. I got an idea. I'm going to color the inside. Oh, yes. Is that better? Can you imagine now this dog dish? This dog dish is hollow in the inside, following that blue line. And this part between the green and the blue, you have to imagine that being rotated around, and we get a dog dish. This is a very expensive dog dish because we've made it out of platinum. It's also somewhat impractical because there's a tiny hole at the bottom. Whether or not the hole is tiny enough that the water won't drip through, it's just a single point. And since a single point doesn't have any area, technically there's a hole there, but it's smaller than a water molecule, so it should be okay as far as imagining this. So here we have our platinum dog dish. You've designed it, you're super excited. So now you go to your local Home Depot where they sell platinum bulk. Yeah, right. And figure out how much you need to buy to melt it down with fire in your backyard to make this. Should be pretty straightforward. So how do we do this? Well, what we need to do is we need to find the volume of the one shape in its entirety first, and then subtract the volume of the other shape after. So what's the volume of our one shape? Well, under the green, and I'll do this work in green, we would go our integral from 0 to pi over 4 of pi, and radius squared would be, is it all right if I put the squared between the n and the x? Are you okay with that? Dx. Then we would need to subtract, pi over 4, thank you. We would need to subtract the volume from 0 to pi over 4 of pi and then cos squared dx. How's that? Everything good? No. Should be cos minus sine. Good. Almost good. Should be cos minus sine. Excellent. Any problems you see at the moment, now that we've written it right? I see a problem. How do you integrate cos squared? We have an integral for cos, but cos squared has the squared, so it's a function inside of a function, which would need substitution. But if you let u equals cos, the derivative of cos is negative sine, but it doesn't appear here. So that first one we can't integrate. It won't work, because what we want to divide by is a whole other function. But we do have a rule, our properties of integrals, that say an integral minus an integral is the same as just subtracting them inside. Woo, that's a beautiful S. Now, does that help us any? Why? Because it's an identity. If I factor out the pi, if I bring the pi out in front, cos squared minus sine squared is cos 2x. And now we've changed it into something we can integrate. So before, both of those individually, you could not integrate. But cos of 2x, we can integrate. That will be sine 2x, and we have to divide by 2 because of the chain rule. So we'll have sine 2x divided by 2 from 0 to pi over 4. And at this point, we plug in. If you plug in pi over 4, you get sine of pi over 2. What is sine of pi over 2? 1. So it becomes 1/2. And when you plug in 0, what's sine of 0? 0. And so you go to a worker and say, I would like to buy pi over 2 units cubed of platinum, please, so that I can make this wonderful dog dish at home. Units cubed. What would you like to make the units? Centimeters? You got a big dog. You can make these in meters. Kilometers cubed, the biggest dog dish in the world. Yes. How much would it cost to buy? Let's do centimeters, because that's pi over 4 centimeters, though. That's too small. That's a fill it up again. Right? What would be inches? But look, we have to come up with pi over 4 is like 3/4. So that's its depth. And this, I guess, its diameter would be 2 at the base. So what would 2 feet? Yeah, it's pretty big. What is there a good unit that we could use that would be 2 something? 2 decameters. It sounds. Ugh. Who uses decameters? Right? All right, we'll do feet. We'll use that this is a foot. It's a rather big, maybe you have it, so you need pi over 2 feet cubed. Someone's going to look up the current cost of platinum per foot cubed. You might have to do some calculations and find out how much this is going to cost us to make this.